Hello everyone, I am Raksha, a computer science BTech student. So this is my first presentation of the task 3. Today I want to discuss a topic that is often overlooked in technical documentation, the mental model. We are here to talk about the liquid galaxy, but more specifically, we are here to talk about the visual gap, that frustrating space between when you run a command and when you actually see something changes happening on the screens. When I began working with the Liquid Galaxy, I made a fundamental error. I assumed that because my background was in the traditional application development, that may be the mobile or the web applications, building the things for a single screen or a single user. So, in that world, the execution and the output are twins. They happen hand in hand and they also happen with together. Now, I remember my very first night of the Liquid Galaxy setup. The room was quiet, the screens were on, and I was at my terminal. I typed my command. I hit enter and I saw a beautiful and a clean prompt written. No errors, no warnings. But when I looked at the Liquid Galaxy screens, they were motionless. My heart sank. I thought I had failed and I thought the hardware was dead or my installation was corrupted. But what I want to prove you all today is that my system wasn't broken. The perspective was. Today we are going to look at why the liquid galaxy behaves the way it does and how can you save yourselves dozens of hours of frustration by simply changing the way you think. Now, you might ask that why does it even matter that what I think as long as the code works? Now, listen to me. It matters because a developer's state of mind determines their productivity. Misunderstanding the architecture of the liquid galaxy leads directly to what I call is the loop of frustration. Now, when you expect an instant result and don't get it, you enter a state of technical panic. You start rechecking the configurations that are already correct and you start rereading the documentations you already know. And also, you start fixing the things that were working perfectly. I spent hours in this loop. I would run a command, see no response, and immediately assume I had made an error. Now, I would start debugging my network, my SSH keys, and my KML syntax all at once. By the end of the night, I was exhausted and hadn't moved forward at least for 1 inch. This presentation is designed to stop that loop. We are going to learn to trust the system's asynchronous and event driven nature so you can work with the calm and precision. Now, let's break down the synchronous mental model. In a standard application like a Python script or a basic mobile app, the environment is a closed loop. Input, you click it, logic, the CPU processes, and the output, the screen is updates. This happens in milliseconds. It's a handshake. You give, the computer gives you back. During my Liquid Galaxy setup, I subconsciously forced this model onto a system that does not support it. I would run a script and think the script is finished, so the visualization must be finished. Now, the realization came when I understood that the liquid galaxy is not a light switch. It's more like a global logistics system. You don't flip a switch, you need a shipping container. Just because the container left the port does not mean it has arrived at your house. The fix for me was a mental reboot. I had to consciously tell myself, forget the handshake, start thinking about the pipeline. Now, the liquid galaxy is a distributed visualization system. This isn't just a fancy term, it's a hardware reality. You are dealing with the cluster of independent machines. Imagine an orchestra. The controller is the conductor. the display notes are the musicians, and the conductor does not make a sound. The conductor only waves a baton. If the conductor waves for a loud C major chord, the sounds does not happen. The exact microseconds the baton moves. The musicians have to see the baton, lift their instruments and play. In Liquid Galaxy, the controller runs in one environment while the visualization is produced by multiple machines running the Google Earth. My mistake was assuming that the conductor was also the musician. I would trigger an action and look at the screens expecting the conductor's speed. But I had to wait for the orchestra's response. Multiple machines, network latency, and rendering engines are all involved. Displays or of the that delayed are not the bugs. They are the physics of the system. Now, this is the core conceptual shift, that is the Liquid Galaxy is event driven, not a command driven. Think of a busy restaurant. In a command driven world, you go to a kitchen and flip your own steak. In an event driven world, you give a ticket to the waiter takes the ticket and puts it onto a hook in the kitchen, and the chef eventually gets to it. During my setup, I was the customer who kept shouting my order at the waiter every 5 seconds because I didn't see my steak yet. I would click the buttons repeatedly. I would run the same SSH script 5 times in a row. Internally, the system was registering every single one of those events. I was just stacking the tickets on the hook. I remember thinking, I'll check again because the first one failed. But the first one hadn't failed. It was just in the kitchen. By sending a second, a third, the fourth event, I was actually confusing the chef. The fix is that send the event once, trust the queue, give the system space to cook your request. Now, let's get very technical. Let's trace a single action, updating a KML view. The trigger. You press on your Flutter controller. That signal travels over Wi-Fi to the master node via SSH. Now, the SSH command runs a script that overwrites a file. Let's call it a master.kml. Now, the OS confirms that file is saved. So, this is where the terminal says success. Now, the Google Earth has a link refresh timer. It checks the files every few milliseconds or the seconds. Then at last, the Google Earth sees the change, calculates the new 3D perspective and draws it. I spent one whole night staring at a setup 4. I would cat the file, see it was correct, and then look at the screen and see it was wrong. I thought the system was lying to me. I didn't realize that step 5 and the 6 take time. If you don't understand this 6th step pipeline, you will waste your life trying to fix this step 3 when the delay is actually happening in step 5. The fix was realizing that SSH success is the only beginning and not the end. Now, as the developers, we are trained to love the message exit status 0. It's our comfort zone. In my early debugging, I would see command executed successfully and think, okay, that's done. Why is the screen still blank? I would then start debugging the permissions, or I would restart the whole machine. I was equating that execution success with the visual success. Now, in a distributed visual system, these two are completely decoupled. Your code can be perfect, your SSH can be 100% stable, and your terminal still can be clean, but the visualization can still be in progress. I had to learn to separate these two truths. If the terminal says success, I stop touching the keyboard. I move my eyes to the screen and I wait. Separating these concepts was the single greatest fix to my mental health during this project. Now, asynchronous behavior. Asynchronous is the ghost in the machine. I remember editing a KML file to add a complex 3D tool. I hit slave. I looked up. What did I see? I saw one screen move while the other two stayed still. Then 5 seconds later, the others caught up, but the map was just blurry mess of low resolution pixels. My thought was my KML syntax is broken and I must have a typo in my the coordinates. Now I spent an hour recoding the KML. Now the KML was fine. What I was seeing was the asynchronous reality. The master node had updated, but the sleeve nodes were still downloading the 3D data from the internet. The textures were blurry because the rendering engine was still fetching the data. Now, what was the fix? The fix is that I learned to give the system breathing room. If I saw a broken visual, I would count to 10. Usually by 7, the visuals were fixed by itself. Now, one of the most dangerous habits a developer can have with a liquid galaxy is aggressive retrying. When you don't see a result, our instinct is to push harder. We run the command again. We hit the button harder. In our heads, we think we are reminding the system, but in reality, we were interrupting the system. Every time you send a new command while the system is still rendering the old one, you risk creating an inconsistent state. You might crash a script or cause Google Earth to freeze because it's being bombarded with contradictory view sync packets. Now, the fix was hard rule for myself. One action, 10 seconds. If I send the action, I do not touch the controller for 10 seconds. This discipline changed everything. So, what is the zen of the liquid galaxy? It's the shift from control to request. In a traditional app, you are a dictator. You tell the pixels where to go and they go there. In liquid galaxy, you are a client. You are making a polite request to every complex, very busy and cluster of computers. You submit your request and you trust the system that will fulfill it as soon as its resources allow. Once I adopted this mindset, the delays weren't annoying more. They were just the system's processing timing. This made the work predictable and it made the errors easier to spot because I wasn't clouding the logs with my own frustrated retries. Now, let's look at how this applied to the Flutter development in my task 2. So, I was building a controller, a tool for others to use. Now, I would press a button in Flutter, trigger a process, run for SSH, and look at the screens. When the screens didn't move, I immediately assumed my Dart code was bad. I thought maybe the SSH library isn't working, or maybe the future isn't completing. Now, I added hundreds of print statements. I spent a whole afternoon debugging a Flutter SSH client that was already working perfectly. The realization? Yes, the command was arriving at the liquid galaxy. But the visual response was lagging behind my app's execution speed. I was trying to fix a Flutter problems that was actually a Google Earth reality. The fix was learning to trust my logs. If the log says send, then the code is done. The reset is up to the galaxy. Now, this created a massive design problem. If I show a success message in the Flutter, the moment the SSH finishes, the user gets confused. They see the success on their phone but nothing on the screens. I realized that the Flutter app is blind. It cannot see the screens. It has no idea if Google Earth is rendered or crashed. So I had to stop my UI from lying to the user. Now I redesigned the statement management. Instead of check mark that means it has happened, I used to indicators that mean the request has been delivered. I used loading spinners that lasted a bit longer to manage the user expectation. Now, the fix was aligning the UI with the system's asynchronous nature. Now, we aren't building a remote control, we are building an event submitter. Now, looking back at my entire journey from the first time I turned on the machines to the final Flutter build, every mistake I made followed the same pattern. First is I expected a single system response. Second, I mistook the latency for failure. Then the third was I trusted my eyes more than the architecture. Now, these fixes were almost never about a fixing code. They were about fixing a thought. Liquid Galaxy is distributed, asynchronous, and event driven. If you respect those three technical realities, the system is a joy to work with. If you fight them, the system will break your script and the spirit that you have while doing that. But understanding the visual gap is the most important technical skill that I have learned during my journey. Now, to conclude, working with the Liquid Galaxy is a master class in modern system architecture. The challenges I faced weren't the bugs, they were the lessons. Whether I was struggling with an SSH setup or trying to manage the state in the Flutter app, the answer was always the same. That was just slow down, observe, trust the pipeline. So, once I aligned myself, the expectations with the system's design, everything became clearer and more predictable. Now, the Liquid Galaxy is a powerful, beautiful system, but it demands a specific kind of developer. The one who is patient, the one who understands the networking, and the one who knows the difference between the command sent and the pixel rendered. This project hasn't just taught me how to use the Google Earth, it has taught me how to think about the complex distributed software. Thank you for listening to my journey. I hope these lessons save you as much as the time they save eventually mine. So that's it for the whole presentation. Thank you everyone for watching. Now, before I wrap up, let me share a specific what if scenario that happened to me. So imagine you have sent a SSH command and your log says success and you have already waited for 10 seconds, but still the screens are still not changing. So in my early days, I would have panicked and started rewriting the code. But once I understood the visual gap, I developed a 3-step diagnostic check that I want to share with you. The first thing is the check the network link. Is Google Earth actually pointing to the correct file path? Sometimes the file updates, but the network link in the Google Earth is still pointing to an old version. The second is verify whether the KML structure. Now, use a validator. A single missing bracket in your KML won't stop the SSH from succeeding, but it will stop the Google Earth from rendering. And also the last one is monitor the resource load. Is the machine's CPU at 100%? Sometimes the visual gap isn't the logic error, it's just the hardware struggling to keep your data. Now, by following these steps, I stopped guessing and started diagnosing the things. So this is the difference between being a coder and being a Liquid Galaxy developer. So that's it for my video. Thank you again.